Good day, I am Luis Martin BALLAIS from BSc 1D, and today we are about to discuss some basic trigonometry topics. The first topic to be discussed for today is the degrees to radians and radians to degrees conversion. Degrees and radians are two units for measuring angles. A circle contains 360 degrees, which is the equivalent of 2 pi radians. So 360 degrees and 2 pi radians represent the numerical values for going once around a circle. Let's work with a few examples so you really get the concept down. Here are the examples you'll be working with. Multiply the number of degrees by pi over 180. To understand why you have to do this, you should know that 180 degrees constitute pi radians. Therefore, 1 degree is equivalent to pi over 180 radians. Since you know this, all you have to do is multiply the number of degrees you're working with by pi over 180 to convert it to radian terms. You can remove the degree sign since your answer will be in radians anyway. Here's how to set it up. Next is to do the math. Simply carry out the number of degrees by pi over 180. Think of it like multiplying two fractions. The first fraction has the number of degrees in the numerator and 1 in the denominator, and the second fraction has pi in the numerator and the second fraction has pi in the numerator and 180 on the denominator. And lastly, simplify. Now, you've got to put each fraction in lowest terms to get your final answer. Find the largest number that can evenly divide into the numerator and denominator for each fraction and use it to simplify each fraction. The largest number for the first example is 60. For the second, it's 30. And for the third, it's 45. But you don't have to know that right away. You can just experiment by first trying to divide the numerator and denominator by 5, 2, 3, or whatever works. That's how you do it. And so, we derived on our final answer. The 120 degrees is equivalent to 2/3 pi radians. The 30 degrees is equivalent to 1 over 6 pi radians. And the 225 degrees is equivalent to 5 over 4 pi radians. Meanwhile, in solving radians to degrees conversion, you just simply multiply the given radians to 180 over pi to get its value in degrees. So that's all for our first topic. So our next topic is all about solving right triangles. Let's move to this example. We are given a right triangle. The given is a triangle ABC, and it says that find AC. The first step in solving the given right triangle is to determine which trigonometric ratio to use, or a trigonometric function. So let's focus on angle B, since that is the angle that is explicitly given in the diagram. So the angle B is the 50 degrees. So note that we are given the length of the hypotenuse. Hypotenuse is the longest side of a right triangle. And we are asked to find the length of the opposite side angle B. So the trigonometric ratio that contains both of those sides is the sine. So the next step is to create an equation using the trigo ratio sign and solve for the unknown side. So first, let's write the equation, which is the sine quantity B is equal to opposite over hypotenuse. So that's how we define sine. And next, substitute the values. And after that, divide both sides by 6 to cancel 6. So 6 sine multiplied by 50 degrees is equal to AC. And then evaluate the equation using a scientific calculator, and you will get an answer of 4.60, and that is the value of line AC. So the next and last topic is proving trigonometric identities. So the given must be simplified. So the given is secant x over tan x. So by that, first, by simplifying, we need to rewrite both functions in terms of sine and cosine. So that is why it is written 1 over cosine x over sine x over cosine x. So next step is to divide fractions, invert, and multiply. So, and by that, 1 over cosine x multiplied by cosine x over sine x. So cancel the cosine x. So the remain will be 1 over sine x. And then simplify by using reciprocal identity. So the reciprocal identity of 1 over sine x is cosecant x. Therefore, secant x over tan x can be simplified into cosecant x. That's all.